So let us now discuss some examples. So our first example will concern a concave mirror. So first thing you should notice is that the concave mirror always has the radius of curvature as negative. So say an object is placed at a distance of 20 centimeters from a concave mirror with the radius of curvature as minus 10 centimeter. Now first of all, why radius of curvature of a concave mirror is negative? Now the light is incident like this on a concave mirror, but the radius is measured from this point P to this point C. So this is measured in the direction opposite to that of the incident light. Therefore, by our convention, this would be negative. So we are going to measure this distance r from the point P. So we go from P to C, and therefore you get minus r as the radius of curvature. Similarly, for a convex mirror, for a convex mirror is like this. So this is how the light will fall on it, and therefore for a convex mirror the radius of curvature is positive. So if this is the center and this is the pole, then this distance is positive because we go from P to C, which is in the direction of the incident light. So in case of convex mirrors, the radius of curvature is positive. Now the first thing to notice is that the focal length is minus 5 centimeters. Now this is because of the formula focal length is equal to r by 2. Now you use this formula of 1 by v plus 1 by u is equal to 2 by r. Now the first thing you notice is that the object is placed at a distance of 20 centimeters. So we have placed the object here. So this is our object. So this object is at a distance of 20 centimeters. Again we have to go from P to the base of this object. And since we have to go from here to here, this is the direction which is opposite to that of incident light. So this will be minus 20 centimeters. Now notice that you always place the object in front of the mirror. So in case of a concave mirror also, you will have object somewhere here. So again the distance will be negative here also. So this distance we denote by u. In our formula, the object is placed at a distance u. So u is minus 20 centimeters. So this is where the object is placed. V is the distance of the image. So you just plug it in, solve for v, it comes out to be minus 20 by 3 centimeters. Now v is negative. That means image is on the same side as the object. Now you can draw the ray diagram also. Now for the ray diagram, I told you first to draw through P. So the light falls on the pole and gets reflected by the same angle. So falls at theta and gets reflected at theta. And the second is, if you draw the ray through the center of curvature, it falls say at a point here, then it gets reflected back at the same point. So this is the angle or the point of intersection, and this determines the image of the object. So V is negative means that the image lies on the same side as this object. So image lies on the left of point P. So negative sign means that image lies on the left of point P. So therefore it is on the same side as the object. Magnification we defined as minus V over U. So you can say minus V, we have found minus 20 by 3. So plug it in, you get minus 1 by 3. So the negative sign indicates that it is inverted. So you can either solve this numerically without worrying about the figure, or you can actually draw the figure and see. So in the figure you can see that the image h prime, so if the arrow is facing upwards, the image h prime is facing downwards. So the negative sign indicates that it is inverted. So the negative sign here shows that the image would be inverted. And you can also see this h prime is approximately 1/3 the height or less than the height of h. So ray diagrams do help us solve numerical problems, or you could just solve numerical problems without worrying about the ray diagram. So these are two sides of the same coin. Now we solve a problem of a convex mirror. So first thing is you rearrange this equation. So that is 1 by v plus 1 by u. Instead of 2 by r, I will write 1 by f. And then you can rearrange this. So rearranging means you first multiply both sides by u. So you get, this implies u by v plus 1 is equal to u by f. Now you simplify this, you write u by v is equal to u by f minus 1, which is u minus f by f. So now you multiply both sides, you multiply u by f and you interchange v and u minus f. That is, you take v here and take u minus f here. So you get fu over u minus f is equal to v. So basically we have done nothing, we have just rearranged the mirror equation. So the idea is that the rear view mirror of a car is a convex mirror. So generally the rear view mirrors in cars, bicycles, scooters, etc. are all convex mirrors. So suppose you're sitting in a parked car. Yeah, so suppose you are sitting in a parked car and there is a bicyclist which is moving at a speed of 5 meters per second just behind you, and you are given this focal length is equal to 1 meter for the mirror. Again, notice that f is 1 meter because we are talking about a convex mirror. So the radius of curvature of this mirror is 2 meters. So therefore the focal length is 1 meters, and since it's a convex mirror, this is positive. So when the bicyclist is at a distance of 39 meters from the stationary car, so you're sitting in a car, you're looking at your rear view mirror and you see someone biking behind you at the speed of 5 meters per second. Now when that person is exactly at 39 meters, say you have marked the road and he is exactly at 39 meter point, now the bicyclist will appear to be at a distance of, so you will see the image of the bicyclist. So you see the image of the bicyclist, so you just plug it in. So f is 1, so u is minus 39 because you're always placing the object in front. So let us see this in a diagram. So this is the point P and this is where the bicyclist is. So this distance is, we are always saying, is u is the distance of the object, and u is always negative because you place person in front of the mirror. You going from P to the base of this object, and this is 39 meters. So you put u as minus 39. Again u as minus 39. This is u. So this is u. So f is 1. This 1 is f right here, and the minus sign in front of f is this minus sign. So this is nothing but u minus f. U is minus 39. So this gives you 39 by 40 meters. So when the bicyclist is behind you by 39 meters, you see the image in front of you as 39 by 40 meters. So let us see this in the figure. So again, we have seen this before. For a convex mirror, you put a parallel beam of light, it appears to diverge. So the beam of light comes on like this, falls on the mirror and then diverges, but this appears to be coming from the focus. So this is where it is coming from. Now if the beam of light falls as if it is going from the center, then it reverts in the same direction. So then it will go back in the same direction. So you take the point of intersection right here, and this is the image of the object. So if this distance is 39 meters, this distance seems to be 39 by 40 meters. So in 1 second, bicyclist will move 5 meters, yeah, because the speed of the bicyclist is 5 meters per second. So thus the position after 1 second is 34 meters. So it was initially, he was 39 meters behind you. He travels for 1 second by 5 meters. So 39 minus 5 gives you 34. Now again you plug this in the formula. So this is F is 1, this is F, this is U. So this is U is minus 34. You get 34 by 35 meters. So the shift in position of the image in 1 second. So in 1 second, so in the previous second it was at 39 by 40 meters. Now it is at 34 by 35 meters. So the shift is 1 by 280 meters in 1 second. So the speed which appears to you is 1 by 280 meters per second. So the actual speed of the bicyclist is 5 meters per second. But if you observe him in the mirror, it is 1 by 280 meters per second. So before we close this chapter, I just want you to focus that suppose you want to again draw this ray diagram for the convex mirror. So you could again focus on just the point C and the pole. So you know if the ray is going towards point C, it will get reflected back, same point. What if you send the ray to point P? So if you send the ray to point P, this is how the ray will go about. So this is the path of the actual ray. So the red is the path of the actual ray. So the ray goes like this and then it goes like this. But if you have to draw it backward, it will again intersect at this point. So you can again get the object right here. So our rule of thumb for drawing these diagrams is this: you have to draw at the point P, which is the pole, and second you have to draw at the point C, which is the center of curvature. So center of curvature is very easy. So the ray which strikes the mirror, if you strike at certain angle, you will also come back at the same angle. For the pole, if you strike at an angle theta, you come back at an angle theta.